warm up. Okay. When you're given, and you know what, guys, this is from Unit 1. It's going to be a little flashback to Unit 1 here. Given that f of x equals 5x squared and g of x equals x minus 2, well, we're going to see what each of those are. All right, we're going to complete those. So let me see. Number 1, f of negative 2. So when I see this, this means that I need to plug in negative 2 in for the x of my f function. Do you agree? Okay, so I have 5x squared. The reason why I put parentheses in place of my x is because I can just plug in negative 2. Do you agree? So if you were to plug this straight into your calculator or do order of operations, negative 2 squared is what? It's negative 2 times negative 2.
4.
Times 5. 20. So this is 20. Right? Not bad. Well, let's look at number 2. So g of 8. Well, now it means you need to go get your g function, and you're going to plug in an 8 for that x, right? This thing here inside the parentheses next to that function letter tells you what you need to be plugging in for that x, right? So g is x minus 2, and we're going to plug in that 8. What's 8 minus 2? 6. All right, there you go. Done. Right? So good, right? And that is from Algebra 1. So hopefully you guys remember that from Algebra 1. So if they give you a number, your answer is going to be a number. If they give you x's, then your answer is going to be x's. Okay? So if I look at number 3, I have f of x minus g of x. Well, your f function is 5x squared minus your g function, which is x minus 2, right? And the reason why I put parentheses around that x minus 2 is because that is my whole entire function, right? And the thing is, anytime you have a subtract in front of, you know, like a big, more than one term unit, what do you have to do to this? Having that negative in front is like having a negative 1 in front, right? So you have to distribute that negative. Does that make sense? Anytime you see a minus with these guys, just remember, oh, I could be distributing the negative, okay? So what do we have? 5x squared. What's negative 1 times x? What's negative 1 times negative 2? No, negative times a negative? There you go. Can I combine anything? No. So this is it. All right? All right, so the last one would probably be the most confusing. G of f of x. Guys, it's still the same principle, okay? You have your g function, but instead of the x in your g function, what has to go in? Your f function, okay? The whole entire f of x. So this whole entire guy has to go in for the x of your g function. So my g function is x minus 2, right? What is my f function? (5x squared), right? So now you have that 5x squared minus 2. Can you combine anything? Nope, so it's just 5x squared minus 2. There you go. Done. All right? Questions? Okay. Okay, so day 2 of our lesson no, of our unit 8A, right? We're going to look at compositions, okay? The thing is that most of this is a review. We're only adding a couple of things that are new, all right? So if I look at, oh no, not number 4. Hold on, where are we? Here. So number 1. Up at the top, you guys have a table of 6 different functions, right? And they all have a special name. So like f function is f of x, g, h, and so on, right? So number 1 says h of 20. Well, that means you need to go and get your h function, which is square root of x minus 4. But instead of this x, what do I need to plug in? 20. Yeah, inside the parentheses. That becomes your x, right? Okay. And whenever you guys plug in for the x, use parentheses. All right? It's a good habit. So, inside the square root, guys, what is 20 minus 4?
16.
Yeah. So, square root of 16. And can I simplify this even further? What is the square root of 16? 4. Good. There we go. That's it. Done. All right, let's look at the next one. So the next one is just, 3 steps. First thing you're going to do is you're going to go find g of 3. So go get your g function, which is x minus 4. But instead of that x, you have to plug in what? 3. You see that? What is 3 minus 4? Come on now. It's $3, you give away $4. Negative 1, you owe $1, right? And then plus, all right, let's do this one. F of negative 1. My f function is 2x cubed plus 2, x cubed plus 2. Yeah? But instead of that x, what do I have to plug in? What is with the f here? Negative 1. It says to plug in negative 1. So you could literally put that whole expression into your calculator. Your calculator will do the order of operations for you. But if you wanted to do it, just mental math, you can. Negative 1 cubed. Negative 1. What do you get? What do you get here? Times 2, then plus 2. What do you get, Ethan? I feel like you could do the mental math. I thought you were concentrating. Oh no! Let's pay attention. What did you get, Abner?
0.
0. Thank you, Dylan. 0. What's negative 1 plus 0? Negative 1. So that is your final answer here. Okay? Do you guys see what I'm doing? Is anyone confused? All right. So let's look at number 3. So number 3, I have k minus j of x. Well, for this one, first of all, they didn't give me a number, right? It's an x. So my answer should have an x. And here, they combine the k minus j. And whenever they do that, I kind of like to just take it apart. K of x minus j of x. It's the same thing, but it just makes me see it a little bit better. So my k function is x squared plus 4x plus 3. Right? And then minus, what's my j function? Look up at the top at your table. What is that j function? J of x. Yeah, 4x, all the way up there, right? So normally, if I could, I would distribute, wait a minute, but there's no plus or minus, so it's just really minus 4x, right? Okay. So let's see. X squared plus 4x plus 3 minus 4x. Combine like terms. What can I combine? 4x and then minus 4x, right? What is 4x minus 4x? 0. All right, so what's left over? X squared plus 3. There we go, done. Questions? All right. Okay, so number 4 says given all of those, same ones. All right, f of negative 2 times m of 4. So guys, we're doing the same thing that we did before. We're going to plug in a negative 2 into the x of my f function. We're going to plug in a 4 into the x of my m function. And then what are you going to do with the two answers? Yeah, what is this? What is this operation right here? Multiply them. All right, so let's do it. F is 2x cubed plus 2. M is square root of x plus the 1. Right? I want you guys to plug in those numbers. Give me the two answers. Let's see what you get. Negative 2 gets plugged in for the x for my f function. And 4 gets plugged in for the x for my m function, right? In terms of my f function, let's see. 2 times negative 2 cubed plus 2. Negative 8 times 2 is negative 16 plus 2 is negative 14. Yeah? Okay. Times, what's that? Square root of 4 is 2 plus the 1, so it's 3, right? So what is negative 14 times 3? Good. So it's negative 42. Are we okay with that? All right. So the next one, k plus f of 2. All right, you know what? I don't really like it combined together like this. I'm going to separate it. It's k of 2 plus f of 2. I want you guys to do this all by yourselves. Try this one. I want you guys to keep working. I'm going to put up my work up here, and then we can compare. Did I do this right? Is it 15 plus 18? Good. 15 plus 18 gives you what? Good. Perfect. All right, so number 6, we have f of x minus g of x. Now in this case, you don't have numbers, so you're not going to get a number answer. All right, we're going to have an x in our answer. That's fine. F function is 2x cubed plus 2 minus my g function, which is x minus 4. Guys, I have a minus sign in front of parentheses. It's like saying there's a negative 1 there. What do you need to do? Distribute that negative. Good. So I have 2x cubed plus 2. Remember the first one? It doesn't affect the first one. You can't distribute backwards, right? Negative 1 times x gives me negative x. Negative 1 times negative 4 gives me a positive 4. Do I leave it like this? Should I stop here? No, Cindy. What should I do? You're right. Thank you. Combine like terms. So it looks like I can combine this 2 and the 4. So I have 2x cubed minus x plus 6. Down the bottom now, let's talk about what we learned in Unit 1 about compositions. Okay? So compositions can be written like this. They can write it this way. F of g of x. They can say the whole entire g of x gets plugged in for the x of your f function, right? I like this way. This way is the easiest to kind of read. But, you know, they can also write it this way, the fog way. And I call it fog because it uses an open circle. Open circle means composition. If it was a closed circle, it would just be multiplication. Okay? So let's try our example then. They gave us f of x, they gave us g of x. So let's try f of g of x. My f function is 2x minus 3, right? But the reason why I left my x blank is because what do I need to substitute in for that x? The g of x, right? The whole entire g function goes in for the x in your f function. And your g function is negative x plus 5. Does that make sense? All right, and then now we would have to simplify. So we need to distribute that too, right? So 2 times negative x gives me negative 2x. 2 times 5 gives me 10. And minus 3 at the end, right? Now, if we combine like terms, you have to just combine the 10 and the negative 3. So then you just get negative 2x plus 7. Do you agree? All right. You ready for the next one? G of f of x. They use the fog way with the open circle, right? So I'm just going to rewrite it. G of f of x. And remember, it goes in order. So my g function is negative x plus 5. Now, what goes in that x? What do we have to put in there? No, the f of x, right? What is your f function, Zane? Huh? Your f function is that guy right there, 2x minus 3, right? Yeah? Does this make sense? Kinda? Talk to me. Yeah? Okay. So now, oh, I have a negative in front of that parentheses. Distribute. Good. So this turns into negative 2x plus 3, and then please don't forget to bring down your plus 5. And then, of course, you need to combine like terms. Then we have negative 2x plus 8. All right, so let's look at number 1. So number 1, that's not the fog one, right? That one's just a multiply because it's a closed circle. So I'm going to rewrite this. I'm going to say j of x times k of x. Now go and look. What is your j function? 4x. Okay, so I have 4x times, what's my k function? Oh, it's kind of long, right? X squared plus 4x plus 3. Okay. So now I have to distribute because all of that trinomial is getting multiplied by 4x. So what is 4x times x squared? 4x to the what?
4x cubed.
Yes, good. And what's 4x times 4x?
One squared.
Well, what is that?
8x
What is
squared.
4 times 4?
16.
Good. So 16x squared. Okay? Because you're right, is, you know, know that it's in parentheses there. What's 4x times 3? 12. X, good. And there we go. And then I'm done because I can't combine anything. No like terms to combine. Are we okay with that? All right, well then let's look at number 2. So this is a new one. Dividing. You know, dividing is pretty easy. The good thing is that you know what to do. Whenever you divide something and you have polynomials, you can factor and see if anything can cancel out, right? These are probably just going to be like non-factoring ones. F of x, your f function on top is 2x cubed plus 2. What is your j of x that goes on the bottom? What is your j function? 4x. Can you factor any of those?
No.
No. So you can't cancel, you can't simplify, that's it. This is done. Okay? Let's divide. Just put one on the bottom, one on the top. That's it. See if you can factor. So let's look at this one. H of g of x. So I'm going to go get my h function, which is the square root of x minus 4. Why did I not write the x? Kevin, why did I not write the x here? What needs to go in there? Good. That g of x, which is x minus 4. Are we okay with that? So now, combine my terms inside your radical. What's x minus 4 minus 4? What's negative 4 minus 4?
0.
Ah, no, negative 4 minus 4. Good. So it's x minus 8, square root of x minus 8. And then that's it. You know, that looks like underscore, so I'm going to fix that a little bit there. There we go. Okay? Are you okay? Are you okay with this? All right. Oops. All right. So, here's the thing. Most of these function operations and compositions, they're good. Okay? You can plug in any number. It should work. It should be able to spit out a number back to you. Okay? The thing is that, you know the numbers 2 and 3, those two problems that we just did, there are some issues with those. Okay? There are sometimes things called domain restrictions. All right? And that means that there are some numbers that you can't plug in for x because it's not going to work. Right? Because, guys, what does it mean that there's a restriction? Can't do it. Right? So that's what they're saying. What are the restrictions? What are the ones that you can't do? All right? So here's some things I want you to ask yourself. You have to ask yourself, is it a fraction what you have? All right? Because if it is, then there's a restriction. Okay? So let's think about this. Ethan, for fractions, just think back to, you know, your previous math classes, right? If you have a fraction, what is the rule about fractions? Like, you can't have something. Like, can I have a 0 on top? What's 0 divided by 5? 0, right? But 0 is still a number, right? Isn't it? It's still a real number. Well then, how about if I did it the other way? How about if I said 5 over 0? It'll be what? Put it in your calculator. It's error. Why? Why is it error? What happens when there's a 0 under? Huh? Okay. Well, but you could have 5 over 1. That works. That's 5. So you can't divide by 0. Guys, if you have a 0 under, this is undefined. Okay? You can't have a 0 on the bottom because then it's undefined. So, the denominator of a fraction cannot equal what? 0. The bottom part, the denominator of the fraction can't equal 0. Then it doesn't work. It's an error. And then the second question I want you to ask yourself is it a radical? You know what I'm going to do with this? Ask yourself, is it a radical? Is it a square root? And we're only going to do square roots in here. But is it a square root? Well, think about square roots, guys. Okay? Think about this. Are there any numbers that I could put in that square root that won't give me a real number? Negative. Good. What happens if I put a negative in there? What happens if I put a -4? What is that? What's the square root of -4? 2i. Remember, if there's a negative inside the square root, an I comes out. Now it's an imaginary number. And we can't say imaginary numbers are real. They're not, right? So we don't want negative numbers. All right, that's fair. We can say negative. Negative is smaller than 0. Question for you. Can I use 0?
Yeah.
Put in the square root of 0. Tell me if it's I. What's the square root of 0?
0.
0? Oh, but 0 is still a real number, right? Okay. So you know what? 0 works. So that means that underneath the radical, it can't be negative. Cannot be negative. Basically, less than 0, right? But it can be equal to 0, and it has to be greater than 0. Do you agree? Does that make sense, Abner? Yeah? Okay. The other thing I want you guys to write down here, just right underneath it, everything else, it works. Okay? For everything else, there are no restrictions. There is nothing that won't work. So then that means your domain can be everything from negative infinity to infinity. All real numbers. Okay? All right. So, down at the bottom of your page, right? Let's fill in this domain restrictions thing. When you're doing function operations, the 2 domain restrictions that you have to ask yourself, okay? You have to ask yourself, is it a radical? All right? If you say yes, okay. Then underneath your even radical, underneath your square root, it has to be greater than or equal to 0. All right? This is way down at the bottom. We'll come back to those problems. The second thing you should ask yourself is, oh, do I have a fraction? Yes. Okay. Then the denominator, or the bottom part of your fraction, it cannot equal what? 0. Cannot equal 0. Okay? So if any of those things happen, you just have a new domain. You're saying where it can be, what values you can use, all right, minus that restriction. So let's look at the values of x that work for numbers 1 through 3. Good thing is we already did this. J times k of x, we just did it. What was the answer for it? Huh? What was the answer for number 1 up at the top? Right? That was our answer, right? It's the same exact problem. That's why. Alright, so a couple things you need to ask yourself. Is this a fraction? No. Is this a square root? No. So then what's the domain? Are there any restrictions on this? No. So then your domain is all real numbers. If it's not a fraction, it's not a square root, then domain is all real numbers. Is that clear? Okay. So let's look at number 2. What was the answer to number 2?
2x cubed plus 2 over 4x.
Over 4x? Okay. So, a couple things you need to ask yourself. Is this a fraction?
Yep.
Yes. Is it a square root?
No.
No. All right, so we have a fraction here. That means there's going to be a restriction. All right. Remember, for fractions, the denominator, the stuff on the bottom, cannot equal 0. So, what's on the bottom of this fraction? 4x. Okay, so 4x cannot equal 0. Now, solve it for x. Tell me what it can't be. Divide by 4. X cannot be what? What's 0 divided by 4? 0. There you go. That's your domain. It can be any number. It just can't be 0. All right? Does that make sense? Okay. Let's try the third one. H of g of x. If I remember correctly, was the square root of x minus 8?
Yeah.
Okay. So, 2 questions I need to ask myself when I think about my domain. Is this a fraction? No. It's a square root. Good. So, that means, remember, square root. We said it could be 0. Just can't go smaller. It has to go 0 and up. Right? So, everything inside that square root, the x minus 8, it has to be greater than or equal to 0. Yeah? How do I solve this for x?
You get rid of 8.
Yeah. Since it's minus 8, you have to add 8. Then you have x is greater than or equal to 8. That's your domain. Any number, including 8 and greater, right? All right, so our practice problems on the next page. Okay, let's try these. J of x minus k of x. So go get your j function, subtract your k function. So j, 2x squared plus 5x minus your k, which is 5 minus x. But hold on, you have a minus. So what does that mean when you have a minus? Ethan, stay with us, stay with us. We're almost done. Distribute, right? Distribute your negative. So you have 2x squared plus 5x minus 5 plus x. Do you agree? Now, combine like terms, guys. We have the x's that we can combine, right? So we have 2x squared plus 6x minus 5. Now remember the 2 things we want to ask ourselves. Is it a fraction?
No.
Nope. Is it a square root?
No.
Nope. Are there any restrictions then? No. So then my domain is all real numbers. Yeah, negative infinity to infinity. Good. So let's look at number 2. H of f of x. All right, you know I like to rewrite these. H of f of x, right? Now, go get your h function, which is square root of 3 minus x. And I put the x in parentheses because what do I need to plug in? My whole entire f function has to go in for the x in my h function. And my f function is negative 3x plus 2. Right? You okay with this one? Okay. Now, there's a negative in front of the parentheses, guys. What do I need to do? Distribute. Okay.
You get 3x plus.
Yep. Oh, don't forget the 3 in the front. So 3 plus 3x. Uh-huh. And then?
Minus 2.
Good. Can I combine anything? Yeah. The 3 and the minus 2. 3 minus 2 gives me what? Good. So 3x plus 1. Alright. So remember the two things you need to ask yourself. Is this a fraction? No. But it's a square root. So what is my restriction when I have a square root? Gotta take everything inside that square root, and it can be what? First of all, it can be 0, right?
Yeah.
But it has to be what? Smaller than or equal to it, or greater than or equal to it? Greater than or equal to. Okay? And then tell me what that x is. Let's solve. Subtract the 1. Then we have the 3x is greater than or equal to negative 1. Now what?
Divide by 2.
Divide by 3. So what we really have is x is greater than or equal to negative 1/3. That is your domain. Do you guys understand this?
Yeah.
Oh, you're doing such a great job. Like, I'm so happy. This is good. And this is an off day for you guys. So tired. All right, then let's look at number 3. K of x over f of x. So remember with the fractions, it's pretty nice because it might just be what it is, right? K of x is 5 minus x. What is your f function? Negative 3x plus 2, right? And you know, we could factor and cancel out and do all that. You know what, though? Don't worry about it. That's not what we're doing here. My point is here, we just need to figure out domain and all that stuff, okay? Is it a fraction? Yeah. Is it a square root?
No.
No. All right, so we have a fraction. So with the fractions, what is the domain restriction? Everything on the what? Top or bottom?
Bottom.
Bottom in your denominator cannot equal what?
0.
0. All right, so we have subtract 2. Negative 3x is not equal to negative 2. Divide by negative 3. So x just cannot equal 2/3. It can be any number real number. Just can't be 2/3. All right. Questions? Okay. So let's look at number 4, 5, and 6. All right. So number 4, these two are connected together, so I'm going to separate them. F of x plus m of x. So my f function is negative 3x plus 2. Plus, what's my m function? Square root of 2x, and then minus the 3. My goodness. So there's no negative in front of the parentheses, so it's not like I need to distribute a negative, right? So just combine like terms. What are some of the things that you see that I can combine?
2 and negative 3.
Yeah, the 2 and the negative 3. Okay, so negative 3x, and then I'm going to bring over my square root of 2x. What's 2 minus 3?
Negative 1.
Minus the 1. Okay, well there you go. It looks funny, but that is what it is. Now, for the domain restrictions, a couple things you need to ask yourself. Do you have a fraction?
No.
But do you have a square root?
Yeah.
Yes. Do you remember what the restriction is on the square root?
Can I equal 0?
It can't equal 0. It can be 0, except it can't be what? Less than or greater than?
Less than.
Yeah, it can't be less than. So you gotta go greater, right?
Yeah.
Because we're trying to say what it can be, right? 2x, it can be greater than or equal to 0 because it came from inside the square root. And Sabrina, the reason why we don't want it to be smaller than 0 is because then it turns into negative. And what happens when you have a negative inside a square root? I comes out, right? And then now we're not talking about real numbers, we're talking about imaginary numbers. So divide that by 2. X is greater than or equal to what? What's 0 divided by 2?
0.
0. Good. There you go. So your x value can be 0 and up. All right? That's what that means. How are we doing? Good. So the next one. Okay, f of j of x. Let's try this one. So my f function is, wait, but I have something inside it, don't I? That j of x. So any x's that are in my f function, I'm going to write them as parentheses. Because I need to plug in my j function into all those x's, right? So my f function is negative 3x plus 2. What is my j function that I need to plug in? Plus 5x, thank you. Right? And then look at that. I can just distribute my negative 3. And let's see, negative 3 times 2x squared. What's negative 3 times 2? Good, negative 6x squared. What's negative 3 times 5x? Negative 15x. And then don't forget to bring down that plus 2. Can I? Oh, yeah.
That's it?
That's it. Well, I was going to say, can I combine anything else? No. So that's it for this. Let's see if there are any domain restrictions on this, guys. Do I have a fraction?
No.
No. Do I have a square root? No. So then what is your domain?
Infinity
Good. There are no restrictions. It could be anything. That's why it's all real numbers. So excited. It's so exciting. Isn't this fun though? Like really, you don't even have to say it out loud, but you know it's fun. It's like a puzzle with numbers. Huh. So look at the next one, g of j of x. So go look at your g function because what you're doing is you're going to plug in the whole entire j function into any x's in your g function, right? Because it's inside the g. Okay, let's see. G is 5 over x. Oh, so 5 over, that's all x, right? And then my j function is, thank you. So that's nice, right? All right, well, I can't factor and I can't do all that. And, you know, like I said, we're not going to do all of that, okay? We're just trying to do our function operations and think about domain restrictions here, okay? Is this a fraction?
Yeah.
Yes. But do we have a square root? No. All right. Well then, let's think about any restrictions on this. For fractions, guys, we said what can't be? Huh? No, okay, no, that's for the square root. Think about fractions. 0, no 0, where? On the top or on the bottom? The bottom. So that means everything that's on the bottom right now in our denominator, not equal to 0, good. Because if your bottom is equal to 0, then it's undefined. Oh, so look at this.
GCF.
Yeah, thank you. GCF, you need to factor this. Oh my goodness, that's so good. Timlin, I'm so happy that you saw that right away. So good. This actually has 2 restrictions, 2 numbers that it cannot be. Oh, that's so good. You know what? You know what? For that, next week I'm gonna bring you something. Thank you, Timlin. Huh? Yup. Don't you tell people about this. I want Black Days, right, to figure it out on their own. Okay? All of you guys. So then that first one, remember, then all the factors get equal to, we have to do those mini equations, right? So then basically, since this one's not equal to 0, then they all get set not equal to 0. So my first restriction is that x cannot be 0. And then this one, so minus the 5. So we have 2x is not equal to negative 5. Divide by 2, right? So x cannot equal negative 5 halves. Do you agree? So you have 2 domain restrictions on this one. Here's your fellow classmate over here spotted the GCF. So when we factor, we were able to do 2 mini not equal equations, right? So good. Next class, you have a mini quiz on this stuff and on the inverses from day 1, okay?